Hello viewers, you are welcome to my YouTube channel. In our earlier video, we look at the derivation of Chebyshev method. In this video, we are going to look at some examples of Chebyshev method, that is using Chebyshev method to solve problems. And we start with example 1. Find the smallest positive root using Chebyshev method for the equation f of s equals to s raised to power 3 minus 5s plus 1 equal to 0. Our initial approximation is s naught equal to 0.5. So making use of Maple, we express this equation at s naught, that is the function f of s at s naught raised to power 3 minus 5s naught plus 1. Differentiating f of s naught, we have 3s raised to power 2 minus 5, and differentiating again we have 6s naught. So at our initial approximation, which is s naught equals to 0.5, we substitute 0.5 into f of s naught, f prime of s naught, and f prime prime of s naught, and we have the following values: minus 1.375, minus 4.25, and 3.0. So we make use of the Chebyshev method, which is equation 4.1. Using the Chebyshev method, able to see that s1 is equals to 0.2134133,930. So after getting our s1, you can go further to iterate, to do the second iteration. To do the second iteration, in the same way, we substitute the value of s1 into the function f of s1. We substitute f of s1 into this function, and with the derivative of f of s1, you substitute s1 into the derivative, the first derivative of the function, and the second derivative of the function, you substitute the value of s1 into it, and you have the following values. And you using these values, f of s1 and f prime of s1, also with f prime prime of s1, you're able to use the Chebyshev method to get your x2, which is 0.2016400669. okay, you can go further to get your x3, s4, s5, and so on and so forth, and you see that you get better approximation as you move further to get your x3, s4, s5. So that is just example 1. In example 2, we expected to find the approximate value of 1 over 7. This is supposed to be 1 over 7. Using Chebyshev method, again we take the initial approximation of as x naught equals to 0.1, and the solution gives, in the same way, we express this approximate value of 1 over 7 in the form of this. We have 1 over, if we say okay, let s be equal to 1 over 7. We say let s be equals to 1 over 7, and what is that value that when we look for the difference between x and 1 over 7, it will give you 0. What will be the value of s? What the value of s that when you subtract 1 over 7 from it will give you 0. Also, we can say, okay, if s is equal to 1 over 7, then 1 over s is equals to 7, and what is that value such that 1 over s minus 7 will give you 0? And that's exactly what we did here. We have f of s. What is that value such that 1 over s naught minus 7, it will be equals to 0. So we are looking for that value that we give a better approximation of this of this function, which is of this value 1/7. So we will differentiate this. The first differentiation will give you this, the second differentiation will give you this, and at this point 0.1 we have the following value for s0, f prime of s0, and f prime prime of s0, and this same value you substitute it into the Chebyshev method as in equation 4.1. you substitute this s1, you substitute those values into this equation to get your x1. After getting your s1, you substitute s1 into the function at s of s1 and the prime of it, like the first differentiation and the second differentiation, and you have these values. These same values you substitute it into equation 4.2 to get 0.1428543310. so you can continue in that manner too, and that this one will give you a better approximation for 1/7. So the next example we are going to look at, we are expected to find the root of the equation using Chebyshev method, and we define our f of s to be cos x minus s exponential s equals to 0. We are expected to correct to 6 decimal places, taking our initial approximation as s0 equals to 1. So in solving this one, giving the solution for example 3, we follow the same pattern in example 1 and example 2 by first stating the function in terms of s0 and looking for the derivative of first derivative of s0 in terms of s0, and second derivative of the function f in terms of s0. After getting the derivative, the function and the derivatives in terms of s0, you substitute the value of s0 which is our initial approximation 1.0 into the equations, and you have these values. These values is substituted into the Chebyshev method as in 4.1 to get your x1. You continue in that pattern to get your x2, and your x2 which is 0.5178954,317. Continue in that pattern doing the third iteration, and you have your s3 which is equal to 0.5177573637. So to get your fourth iteration, you follow the same pattern, getting stating the function in terms of x3 and finding the fourth derivative, and the secondly is supposed to be the second derivative, and you substitute s3, substitute s3, that is the s3 that the value that you got in here, substitute into this equation, and you have this. Use it, that is the s3, this is the s3 that you got in here, substitute it into it, you have the following equation. After getting the equations, you substitute into the Chebyshev method using Mapo software. You have 0.517757 to correct to 6 decimal place. So we have corrected the values of x4 to 6 decimal place. These are the 3 examples that we have looked at using Chebyshev method. Thank you for listening and subscribing to this YouTube channel.